After completing this lesson, you'll be able to understand stairs, use stair components, create multi-storey stairs, and use shaft openings. The objective domains covered are 1.1f, work with stairs. To create most staircases, you can use common components to build a stair assembly, such as rungs, L and U-shaped winders, and landings. For more complex stairs, you can sketch the boundary, define custom treads, and also landing profiles. Steel and timber stairs can be created by using steel stringer profiles and custom tread profiles. Also note that stairs can host reinforcement bar but cannot be joined to other structured elements such as floors. A shaft opening is very useful when there is a requirement to maintain vertical openings that cut through multiple floors. Symbolic lines can be drawn, which are then displayed on each floor that the shaft cuts. In the example shown, the shaft opening is used for lift shafts and also for drainage pipe openings. Go ahead and open up the model 011, work with stairs. You'll notice that the model opens up in the 3D view. Our first task is to create a multi-storey staircase in this section of the structure. To begin, we define a staircase in a plan view. Let's begin by opening up the 00 ground floor plan. We'll then zoom in to the area where we want to create our stair. You'll note here that we have a reference plane which is indicating the starting position of our staircase. To create a stair, on the architecture ribbon, select Stair. Here you'll note that we're using components, and in this case we're going to use the straight component here. Our intention is to create a U-shaped staircase with a half landing. On the options bar, you'll notice here that the location line is set to the right hand side of the stair. We're not having any offset from selected positions. My run width is 3 foot and 6 inches, and I'm going to create an automatic landing as I model the staircase. In the Properties palette, you'll note here that we're using an in-situ concrete stair for Core 1. The base level is set to 00 ground floor, but we want to adjust the top level to be 01 first floor. Now when I do this, you'll notice now that the actual rise height is calculated, and also the desired number of stairs is currently calculated at 17. The actual number of rises that are created is reported here in the Properties as a read-only value. Before I go ahead and create the stair, I just want to check the railing settings. So on the context ribbon, you'll note that we have the railing tool. Let's select this. We just want to ensure that the railings are set to none, as this is going to be a structural staircase. Let's go ahead and select OK. We're now ready to model our components. To begin, I'll snap to the endpoint of our reference plane, and I can now define my first run. You'll note that on screen is displayed the number of rises created and the number remaining. So in this example here, I'm going to create 9 rises on my first run, and then 8 rises on my second run. In the Properties palette, you'll now note that the actual number of rises matches the desired number of rises. Also, our desired stair height is calculated out at 11 feet. On the context ribbon, let's select Finish Edit Mode. And our staircase has been modelled. To help us understand this a bit further, we're going to create a section that's going to cut through the first run of stairs and elevate the second run of stairs. On the Quick Access toolbar, select Section. Create a section that initially runs down this grid here, and we'll then move this or reposition this over the first run of the stairs. I'll change the section depth here just to elevate the stair itself. We can then go ahead and open up that section. You'll note here that the stair isn't quite high enough to reach the top of the slab. The reason for this is that the run settings have start and end with rise. To edit this, I'm going to select the Tab key just to select this run here. Once I have this run selected, you'll note in the Properties palette we have the option of Begin with Riser and End with Riser. So I want to begin with a rise, but I don't want to end with a riser. So I'm going to remove that. Now, this little warning here is now saying that my staircase cannot reach the top of the slab because obviously here I've told it not to end with a rise. The solution here is to extend the length of the run, which will add another step. Click OK to the warning. And here we'll go back to our ground floor plan. We'll select our staircase, click Edit Stair. I can then select this run of stairs, and I can use the grip here to drag the run end and incorporate another step. If I now select the Finish Edit Mode tool, and once again go back into the section, you'll now note that my stair reaches the slab. Next, we'll create a multi-story stair. Switch into your 3D view, and you can now see that we have our staircase that we've just created in 3 dimensions. Also note here that my levels are displaying in 3D. To create our multi-story stair, select the stair, and note on the context ribbon we have the option of selecting levels. Now here I can use a crossing window to select the levels that I want the multi-story stair to span between. If I then go ahead and select Finish, you'll note that the multi-story stair is created. Something to note that if I select the multi-story stair, I can then connect or disconnect levels if I later on add or remove levels from my building structure. Finally, we create a shaft opening to complete our stairs. Let's switch back to the ground floor plan, and we'll note here that we have our staircase now created. On the architecture ribbon, you'll notice we have the shaft command. Let's go ahead and select that. And now on the context ribbon, you'll note that we have 2 modes. We have the boundary line mode, which is where we draw the planned shape of our vertical shaft. And then we have a symbolic line mode where we can draw symbology to represent an opening. Let's begin by creating our boundary lines. So the shape that I want to open is going to be across here, and it's just going to incorporate the staircase itself. In this example, we're not required to create symbolic lines. In the Properties palette, you'll note that we can set our base constraint for the shaft opening. Notice it's automatically going down -1 foot. The reason for this is so it actually penetrates through the ground floor slab if that was a requirement. And it's going to also go up to the top constraint. Now currently it's only going up to the 1st floor. I'm going to change this and go all the way up to the 5th floor. Let's then go ahead and select Finish Edit Mode. Once again, to help us understand this, we can switch back to our 3D view, and we can now see we have a shaft opening incorporated into our slab. If we now switch back to our ground floor plan, and we zoom into the core area, you'll also notice here that we have some additional shaft openings that have been created, and these are incorporating symbolic lines. So for example here, if we select the shaft opening, and we select Edit Sketch on the context ribbon, you'll note here that these items have been created with symbolic lines. Each of those openings will then appear on subsequent floor planes. So if I open up the 2nd floor plane, and we also zoom into the shaft openings here, you can see that they're still displayed. After completing this lesson, you'll be able to understand foundations, place pile caps, create wall foundations, and create foundation slabs. The objective domains covered are 1.1a, Work with Foundations. A foundation connects elements to the ground and distributes load safely to the earth and rock. Revit has 3 main types of foundation elements: a wall foundation, a foundation slab, and an isolated foundation. Each of these elements has relationships to the structural elements that they support. For example, the wall foundation will follow the wall's plane shape and always attach to the bottom. An isolated foundation can be located at a structural column base and again will remain attached and follow the element in plan position as well as sticking to the bottom of the column. Go ahead and open up the model 012, Work with Structural Foundations Part 1. The model will open up in a 3D view. Our first task is to place some isolated foundations down on the top of foundation plan. So in the project browser, let's go ahead and open up the top of foundation plan. We'll then zoom up towards grid B2 and we'll go ahead and place our first isolated foundation. On the structure ribbon, select Isolated. Note on the context ribbon, we have the option of placing the foundations at grids or at columns. In the Properties palette, select the Type selector and ensure that you've selected the Pile Cap 6 pile. To rotate this element, you can move over existing elements in Revit and press the spacebar to orientate the foundation. We can then place a foundation out at grid B2 and another one at B4. I'm then required to place some 4-pile foundations down at C2 and also at D2. So here I'm going to utilise the At Columns tool. In the Properties palette, in the Type selector, we'll now go ahead and choose the 68 by 68 by 35 inch. And now we can make a selection set of our columns. Notice that Revit now places the foundations down at the column bases. We can then go ahead and select Finish. Let's review our model in 3D. So click the 3D view. And you can now see our foundations are placed. So note here we have our pile caps and our piles. Our next task is to place a retaining foundation underneath the walls on the left-hand side of the model here. On the Structure ribbon, select Wall. On the Properties palette in the Type selector, ensure that you've selected Retaining Footing. This is simply placed by moving over a wall, selecting the Tab key, and you can place all the footings in one click. The footings are linked to the wall, so if we start to change the wall's geometry, the footings will update. Let's now take a look at the type properties of these footings. Select a footing that you've just placed. In the Properties palette, select Edit Type. You'll note here that we have a structural usage, and currently it's set to retaining. If I set this to bearing, you'll notice that we have a simple width and foundation thickness. In this example, the foundation will then be centered about the wall. If I set this to retaining, you can see that we can set a toe length, a heel length, as well as a foundation thickness. Note also here that we can actually set an end extension length as well. So in this case, my foundation is projecting 1 foot past the wall. Finally, we place a foundation slab underneath the lift pit. In the project browser, open up -02 lift pit. And then zoom up on the lift pit walls. Here, we are required to place a foundation slab 24 inches thick underneath these structural walls. On the Structure ribbon, select the Slab tool. On the Properties palette in the Type selector, we have Foundation Slab, 24-inch foundation slab selected. You'll notice on the Context ribbon here, we have boundary line selected, and by default, Pick Walls is the placement method. On the options bar, we currently have a 1 foot offset. I'm going to change this to 1 foot and 6 inches. And now, as I select the walls, you can see now that the boundary is created 1 foot and 6 inches from the wall. We can then simply click the green tick to finish the edit mode, and our foundation slab has been created. Once again, we can review our model in 3D. And there's our newly created foundation slab. After completing this lesson, you'll be able to place and set out piling, create linear arrays, and work with model groups. The objective domains covered are 1.1a, work with foundations, and 1.1g, understand the functions and limitations of model groups. A linear array can be used to set out piling with regular distances between pile centres, or used to distribute a required number of piles along an element's length. When the linear array tool is used, you have the option of grouping these elements together. Therefore, if you make changes to the element setting out, all the other grouped objects would update. Certain restrictions apply when grouping elements. For example, if you have a pile that is located on a grid, by default the pile will move with grids. If you then group the piles without the grid, the relationship cannot be maintained. Go ahead and open up the model 012, Work with Structural Foundations, Part 2. The model opens up in a 3D view. Our first task is to place some piling along a ground beam. To do this, we're going to open up the top of Foundation Plan. Let's zoom in to Grid 3, and you'll notice on Grid 3 we have this ground beam passing through this grid position. Here we're going to place 3 piles into the ground beam and then group those piles together and copy them to other locations. So let's begin by clicking the Structure ribbon and then Isolated. In the Properties palette, in the Type selector, ensure that you have Round in situ concrete pile family selected, and here we're going to use our 16-inch diameter, 16-foot long pile. You'll notice in the Properties palette that the level that this is constrained to is -0.1 top of foundation. You'll also notice here that we have a height offset from level of -2 feet. That's how our pile is set out on the soffit of our ground beam. So now we can go ahead and place out our first pile. I'll then place another one at an arbitrary position on this grid here, and another one to the left. We can now use temporary dimensions to set out these piles. So I'd like to try and maintain 2.5 times the pile's diameter. So in this case, that's going to equate to 40 inches. I've selected this pile here. You'll note that the temporary dimensions witness line isn't attached to the correct element. So I can simply drag this to the pile center. And here, again, stipulate 40 inches. So our piles are now set out. The next step is to group these piles together. Now, one of the things we have to be mindful of is the first pile that I placed down is positioned on this grid line here. So consequently, when I group these together, because the grid's not going to be in the group, Revit will show a warning. Let's go ahead and select our foundations. So I'm going to Windows select them, and then we'll use the filter to remove the structural column, so we've only got the 3 piles in the selection set. Notice up on the context ribbon, I have the option of creating a group. Now, as I've said here, you'll notice that these piles are currently set out on grid. Here, Revit is informing us that a structural element will be detached from the grid due to inconsistent group membership. That's fine, we'll click OK here. And we can name the group, so I'm just going to call this one 3 pile setting out. And then click OK. Now, you'll notice here that we can adjust the origin of our group. I'm going to have this on the grid intersection. Okay, so now that we have our group created, we can then proceed to use the group to populate other grid intersections. To do this, if we look in the project browser, we'll notice that we have a folder titled Groups, and here we have Model Groups. Here's our group that we've just created. I can simply drag and drop from the project browser and then place the group down on another grid intersection. If we now go into the 3D view and review our model in 3 dimensions, we'll now see these piles in groups. A nice property of a group is that if I want to go ahead and perhaps change the length of these piles, I can select the group, and on the context ribbon, I can edit the group. Now, it might be here that we have a requirement for the center pile to be slightly deeper. So I've selected this pile here. In the Properties palette in the Type selector, I can use a 16-inch diameter pile, but this time 24 feet long. Note when I click the Finish tool over here, all the groups update. Now, if I didn't want them all to update, I could choose one of the groups and I could perhaps ungroup this, which will convert this back into 3 different elements. Next, we're going to use an array to create a linear pattern of piles. Let's open up the -02 lift pit plan. Here, we're going to place some piling underneath this structural wall here. Now here we have a foundation slab which is 24 inches deep. We need to make sure that the top of the pile is set down 24 inches. So we're going to adjust the height offset from level of our pile. So on the structure ribbon, select Isolated. Notice here that we have our 16-inch diameter pile. Once again, it's 16 feet long. And we'll place our first pile on the intersection of these 2 walls. But note here that we have a height offset from level of 2 feet. Okay, so I'm now going to array this pile. So we can select the pile. And on the context ribbon, we have the Array tool. Let's go ahead and select Array. On the options bar, we have either a linear pattern or a radial pattern. The default is a linear pattern. Here we can stipulate the number of items that we want in the array, and here I'm going to move this to the second item. So I can snap to the original pile that I've placed down, move my mouse to the right, and again here I need to use 40 inches for our setting out. So you can now see that we have our piling laid out. Currently I only have 2 piles. So here we can adjust this. So perhaps we could set this to 8 piles. And you can see that almost takes us to the edge of the wall. Now what I could do here is simply stretch out these piles so I have 8 piles set out along the length of that wall. If I wanted to do that, I could take the last pile here and drag it, and you can see that it would snap to the center line of that wall. Our piling is now set out. Now once again here, if we go into the 3D view, we'll note that that piling now resides inside a group. Of course, if I wanted to change the item inside the group there, I could edit the group, we could select the pile, and as we saw previously, we could change the length perhaps to 24 feet, click Finish, and of course all the piles update. After completing this lesson, you will be able to understand reinforcement, understand cover, and add reinforcement to a column. The objective domains covered are 1.1h, work with reinforcement tools. Reinforcement is required to improve the strength of concrete in building and civil structures. Concrete is very good at resisting compressive forces, but weak when resisting tensile forces. To improve strength, reinforcement bar is used in most structural elements. Revit has many tools to efficiently add reinforcement to a variety of different concrete elements. Reinforcement can be viewed as a solid by editing the view visibility states. Bar marks are added automatically, but starting numbers and rebar containers can be set by the user. As each rebar is modelled, Revit will give a sequential number based on the rebar container and shape geometry. A bending schedule can then report on the number of bars required for each shape and bar mark for the fabrication shop. The numbering is completely customizable and can be controlled by drawing numbers, project or concrete pours and phasing. Reinforcement cover can be set for the entire element or cover can be set independently for each face. Reinforcement cover can be set and stored in the Reinforcement Cover Settings dialog. Go ahead and open up the model 013 Work with Reinforcement Tools. The model opens up in 03 Third Floor Column Detail. In this example, we're going to open 2 views and then tile them together. You'll notice in the project browser, under 3D views, we have a 3D view here called 3D Third Floor Column Detail. Let's go ahead and open that view. We'll now tile the views together. To do this, we can use the keyboard shortcut WT. And then we'll want to zoom all the views. We can use another keyboard shortcut ZA for zoom all. Before we add reinforcement to our column, let's take a look at the cover settings. On the structure ribbon, note we have cover. Let's select cover. Once we've selected the cover command, you'll note that we can see a green dotted line around the column representing the cover. If we want to edit and change this, on the options bar we can set cover for the entire element, or we can pick individual faces. In this case, I'm going to pick the entire element, and then from the drop-down menu I can select a new cover. If I want to add or amend cover settings, I can click Edit Cover Settings, and in the Rebar Cover Settings dialog box I can amend the cover settings or indeed add a new cover setting. Let's go ahead and add some reinforcement bar to our column. On the structure ribbon, select Rebar. On the Rebar context ribbon, you'll note here we have different placement methods. My first option is just to go ahead and place out a shape from this predefined rebar shape browser. Another option would be to sketch the shape of reinforcement, or I could place freeform rebar for more complex shapes. We then have placement planes. Currently, I'm working on the current work plane. However, if I was placing reinforcement into a slab in plan, I might want to place reinforcement on the top surface of the slab, in which case I would use near cover reference. Or again, if I'm placing reinforcement on the bottom of the slab, I would use far cover reference. We then have placement orientation. So you'll note here, currently I'm placing my rebar parallel to the work plane, but other options I would have would be to select, for example, parallel to cover. And now you can see the stirrup is 90 degrees to my view. And another option I would have here is to use perpendicular to cover as well. In this case, it gives me a very similar scenario. To place our first stirrup out, we'll need to set current work plane and parallel to work plane. To select my rebar shape on the options bar, I can select my rebar shape from the simple pull down menu, or I can use the rebar shape browser. Here, you'll notice I'm placing out a T1. As I move over to formwork, you'll notice that Revit previews the reinforcement shape. The rebar type can be selected from the properties palette. So here I'm using a number 3 bar, but for example, if I decide to use a number 6 bar, again here you can see the shape is then previewed. We can also cycle the hooks by pressing the space bar, and you'll note now the hook cycling between each corner. Okay, I'm now going to go ahead and place my first stirrup. You'll notice here that I have a clash between my hook on the stirrup and this L bar. So I'm going to change my shape, so I can select the reinforcement bar that I've just placed. And in the properties palette, you'll note here, I can change the shape. So here, I'm going to use a T2. Note in a 3D view, we can now see that reinforcement bar that I've just placed. You'll notice that the current reinforcement bar that was already placed is viewed as a solid. My first stirrup here is actually viewed as a wireframe. If I want to see this as a solid, I need to edit the view visibility states. In the properties palette, select Edit View Visibility States. And here in my 3D view, you'll note here I have my third floor column detail. I would like here to view this as solid. Now I also would have the option of viewing unobscured, but in this case I've made the elements translucent, so I just need to view as a solid. And you can now see that stirrup shown. Now of course we'll need more than one stirrup in our model. So to do this, we can select our reinforcement shape. And again, on the context ribbon, you'll note we have different layout rules to create a rebar set. So in this case here, I'm going to utilize maximum spacing. And here, I'm going to set 6 inches for my spacing. Once I've set the maximum spacing, I can use the rebar shape handles here to adjust the range of reinforcement bar. As well as doing that, we can also change the layout rules. So here I've used maximum spacing, but another option I could have used perhaps was number with spacing. So here we could specify how many stirrups we want and then the spacing in between each stirrup. Or we could also set a fixed number. But I can use the simple spinner bar here just to adjust the quantity of rebars between the first and last element. Okay, so there are our stirrups placed out. After completing this lesson, you will be able to understand reinforcement settings and understand reinforcement numbers. The objective domains covered are 1.1h, work with reinforcement tools. The reinforcement settings control the general presentation of rebar, how annotations are abbreviated, and how rounding can be applied for scheduling purposes. Within the reinforcement settings dialog box, you can control the bar length, whether it rounds up, down, or to the nearest, and also the bar segment lengths. Reinforcement presentation defaults to showing all the bars, but we can show just the first and last bars, or perhaps just the middle bar. Go ahead and open up the model 014, work with reinforcement tools. The model opens up in the 03 third floor column detail plane. Let's begin by having a look at the process of how rebar numbers are assigned to each element. For example here, if I select this stirrup and then we take a look at the properties palette, you'll notice here that we have a rebar number, currently read-only, of 25. If I go ahead and select one of these L bars, once again here, you'll notice that we have rebar number 10. The rebar numbers are controlled with something called partition. So what I'm going to do here is now add these stirrups to a partition. So you can see I've selected the stirrups, and in the properties palette, you'll note here we have an area where we can type a partition. So here I'm simply going to type C1, which is going to represent column 1. If we now go ahead and select the stirrup again, you'll now notice that the rebar number is number 1. So let's take a look at these settings in more detail. On the structure ribbon, select the reinforcement panel drop-down and then go ahead and select reinforcement numbers. In the reinforcement numbers dialog box, you'll now note here that I have two partitions. The partition we just created was C1, and you'll note here that the starting number is number 1, and here we have 1 bar in use. However, if we look at the next partition, you can see here we have DWG01. It's again starting at bar mark 1. We have 6 bars in the partition. For example here, if I wanted this to start at rebar number 100, I could type in 100 here, click apply, and then OK. And now, if I select the same stirrup, you'll now note that the rebar number is set to 100. We'll now go ahead and place the main reinforcement bars into the column. Select the structure ribbon and then pick rebar. On the context ribbon, let's ensure that we're working on current plane, and for the placement orientation, we want to ensure that we have parallel to cover set. The rebar shape we're going to be using is 00, so once again I can set that here or from the rebar shape browser. We want to just check that we have the number 8 bar selected in the properties palette, and then we can go ahead and start to place out these bars. You'll notice that it will snap to the stirrup. And here in the corners, we should now be able to snap to the center of the bend. So we'll now place out those 4 bars. We'll then go ahead and select those bars, and we'll ensure that it's placed in the same partition, which is C1. Notice now that the rebar number is 101. Once again, if we go to the reinforcement panel drop-down and we select reinforcement numbers, we'll now notice here that we have 2 bars in use from 100 to 101. Go ahead and select OK. Let's now take a look at some of the reinforcement settings. In the reinforcement panel drop-down, select reinforcement settings. In the general reinforcement settings, you'll notice that most of these options are greyed out. If you wanted to include hooks in the rebar shape definition, then this would have to be set prior to modelling any reinforcement bar. We can also set the reinforcement rounding when we're scheduling. So notice here we're rounding to the nearest inch, but of course here we could round up or down. We can do that both for the bar length and the bar segment length, and we can also do that for fabric sheet as well. Let's then select Reinforcement Presentation. Now the default here is to show all the bar in the rebar set as well as in section. What we might want to do here, for example, is just show the middle bar in the set in a view. So the view might refer to something like a plan view or an elevation, but then in section we can still show all of the reinforcement bars. We then have settings for the area reinforcement, so here we can set abbreviations. The same thing for our path reinforcement. And finally for our varying rebar set, so here we can set number bars individually or number bars as a whole. And perhaps set this to A. For example, we might have bar mark 5, and then the varying bars might be 5A, 5B, 5C, and so on. Let's take a look at the reinforcement presentation in another plan view. In the project browser, open the 04 full floor plan. Here, you'll notice that we have a number of rebar sets. In this example here, I'm going to use a crossing window to ensure I get all of the rebar. And on the context ribbon, you'll note here we can show all, show first and last, or perhaps just show middle. So here I'm going to say show middle. And of course you'll notice here now that Revit is just showing the middle bar from each of those sets. If I wanted to adjust this, I could select the bar, click the select button. Here I might want to start by selecting none, and then I can decide which bar I'd like to show, perhaps this one here. Select Finish, and our rebar presentation is complete. After completing this lesson, you'll be able to add path reinforcement and add varying reinforcement. The objective domains covered are 1.1H, Work with Reinforcement Tools, and 4.2A, Develop and Customize Schedules. Path reinforcement is very useful when you need to add U-bars or L-bars along a path. For example, a series of slab edges could be used by the path reinforcement command to populate U-bars around the perimeter. Path reinforcement can also incorporate curves. The path reinforcement by default is grouped within a path system, but you have the option of removing this, which creates separate rebar sets that you can then manipulate as usual. Varying reinforcement is useful in situations where the formwork is skewed or the element's section size is continually changing. In the examples below, you can see two layers of reinforcement added with varying range. The stirrups within the taper beam are varying along the length. Go ahead and open up the model 015 Work with Reinforcement Tools. The model opens in the 04 full floor plan. Before we start creating reinforcement bar, we're first going to open a 3D view and tile these views side by side. In the project browser, go ahead and open up the 3D view. Note we have the two tabs open at the top. We now need to tile these windows side by side. Let's use the Revit keyboard shortcut WT. And also we might want to initially zoom all, so again we can use the keyboard shortcut ZA. Okay, so let's now begin by looking at path reinforcement. We'll zoom up on our fourth floor. Our intention here is to add some path reinforcement around the edge of this slab. To do this, on the structure ribbon, select Path. A valid host for path reinforcement is a structural floor or a wall. So in this case, we'll select our structural floor. On the context ribbon, the default is to create lines around our slab, but of course we could also use pick lines. We have the option of flipping if the reinforcement is on the wrong side of the slab. In the Properties palette, we can then configure our settings. So you'll notice here the layout rule is maximum spacing. Here we're going to use a bar spacing of 10 inches. Our primary bar type will be bar number 3. Our bar length is going to be 18 inches and our primary shape is 17. Let's go ahead and select Finish Edit Mode. Now if we zoom up on the 3D view, we may notice that the U-bars are in the wrong orientation. So here we can select our U-bar and we can press the space bar to orientate these. Another potential issue will be where the U-bars clash in the corner. Now at the minute this is a path reinforcement element. If I select that element, on the context ribbon I can remove the path system. This will then break down the path system into separate ranges that I can then manually take control of. Okay, so our path reinforcement is now complete. Let's now move on to some varying range rebar. In the fourth floor, we'll note here that we have a single reinforcement bar modelled. Our intention here is to create a rebar set for this to distribute it along the slab, but we want the bar to remain the same length but orientated to this edge of the slab. Now on the context ribbon you'll note that the varying range rebar set is activated. I'm just going to temporarily deactivate this and then go ahead and create a rebar set. Notice here that Revit then keeps the bar parallel to the slab edge. However, if I go ahead and select a varying rebar set, you'll now notice that the bar is skewed and following the skewed slab edge. Let's now take another look at varying range rebar on a retaining wall structure. I'm going to close down the fourth floor, and in the project browser, let's go ahead and open section 1. Once again, we'll tile our views so we can use the keyboard shortcut WT. And we'll zoom up on our retaining wall structure. So of course you'll notice here that the retaining wall structure in this particular example here is tapering. The section that we're looking at here is cut at the smaller end of the retaining wall. We're going to create a straight bar in this sectional view and then use the varying range rebar to create a varying range rebar set where the bar length will change. Now you may remember that the reinforcement settings will control how that bar is marked. Let's take another look at this. In the reinforcement drop-down, let's select reinforcement settings. We'll select a varying rebar set, and you'll notice here that we're going to use number bars as a whole, and we've got the suffix A. So what's going to happen here is we'll have the primary bar mark, it may be bar mark 5 for example, and there we might see 5A, 5B, 5C, etc. Okay, let's first model our reinforcement bar. Let's start by selecting rebar. The placement method currently is set to rebar. In this example, I'm going to use sketch rebar. We'll go ahead and select our wall. And here we can sketch our reinforcement bar. Once we've finished sketching, we can select Finish Edit Mode. If I select that newly sketched reinforcement bar, you'll note in the Properties palette that Revit has auto detected the shape, in this case 0, 0. Let's now take a look at that reinforcement bar in 3D. First, we'll set the view visibility states. So in the Properties palette, we can select View Visibility State and then Edit. And here in our 3D view, we want to make this view unobscured and view as a solid. And here's our reinforcement bar. On the context ribbon, let's now create a rebar set from this. So again here, we'll use maximum spacing. We'll have a spacing initially of 10 inches. And you'll notice now that the rebar's length is constant across the tapered wall. However, if we go ahead and select a varying rebar set, what we can now do is use the shape handle to adjust the reinforcement bars. Finally, let's take a look at the schedule. In order for this to appear in the schedule, we need to give it the correct partition. In the Properties palette, type in DWG01. In the project browser, let's go ahead and open up DWG01 rebar schedule. And you'll now notice that we've got our host mark, RW01. So you'll now see that we have the bar mark 1A, 1B, 1C, and so on. This was due to the fact that we've changed our reinforcement settings, and also in the schedule we've combined two parameters together. Let's take a brief look at that. In the properties palette, let's edit the fields. Noting here that I have something called my bar mark. And if I come down and edit this, you'll now notice that this is actually comprised of two parameters. You can see here I have the rebar number and then also the rebar number suffix, which is the A, B, C, D. Okay, so our schedule is now complete. After completing this lesson, you'll be able to add area reinforcement and add fabric reinforcement. The objective domains covered are 1.1H, work with reinforcement tools. Area reinforcement is useful when you want to create two or more layers of reinforcement in elements such as floors, foundation slabs, or walls. You can specify the bar type, layout rules, and spacing for each layer. The area system can be removed, which leaves standard rebar sets that can be edited independently. Fabric reinforcement can be placed by area, by sheet, or can be bent by sketching a bend profile. When placing fabric reinforcement by area, various laps and splices can be automatically added. Go ahead and open up the model 016, work with reinforcement tools. The model opens up in the 00 ground floor plan. We begin by creating some area reinforcement. On the structure ribbon, select area. We are then either required to pick a structural floor or wall for the area reinforcement. Let's go ahead and select this slab here. We can then create our rebar line. Essentially, this is the boundary of our reinforcement. I'm going to go ahead here and use pick lines. I can then pick the boundary for my area reinforcement. I'm also going to pick around the core. The major direction of the area reinforcement is represented with this symbol here. I'm quite happy with that, but if I wanted to change it, I could select major direction and I could then select another boundary line. In the properties palette, you'll notice here that we can set out our layout rules. Currently we have maximum spacing set, but we could also set fixed number. In this case, I'm going to go ahead and use maximum spacing. We are then permitted to create 4 layers of reinforcement. You can see here that we have the top major direction, the top minor direction, the bottom major direction, and the bottom minor direction. In this case, I'm just going to go ahead and select the 2 bottom layers. For my bottom layers, I'm going to use bar number 3. And you can see here we have a bottom major spacing of 10 inches. And we've got the same for our minor direction. I'm quite happy with this, so we'll go ahead and select Finish Edit Mode. To view our reinforcement in 3D, we'll open up the 3D view, Area and Fabric Rebar. I'll temporarily change the visual style to wireframe, and you can now see our area reinforcement added. If I want to make edits and changes to this, I can go ahead and select the area reinforcement, and you'll note in the properties palette I can then amend or add additional layers and change things like the bar type and of course the major and minor spacing. However, if I wanted to remove the area system and create separate rebar sets, on the ribbon here I could select Remove Area System. Next, you create a fabric area on the curved slab. Let's open up the ground floor plan. On the structure ribbon, select Fabric Area. The fabric area can be placed on a structural floor or wall or a foundation slab. Go ahead and select the floor. Once again on the context ribbon, you're required to create a boundary line. In this example, we'll use pick lines. We can then go ahead and pick the lines. And here we'll finish this with the line command. You can see here that this is representing our major direction. And once again, if I wanted to rotate that, I could click major direction and pick another line. However, I do want it traveling this way. And if we take a look at the properties palette, you can see here that we can select our fabric sheet, the location, the lap splice position we want to use. And in this example, we're using minor halfway staggered. And then our lap, which in this case is 12 inches. Let's go ahead and select Finish Edit Mode. We'll switch into our 3D view, and you can now see our fabric area is placed. After completing this lesson, you'll be able to understand rebar constraints and understand reinforcement couplers. The objective domains covered are 1.1h, work with reinforcement tools. When formwork or rebar is edited, it's important that other rebars are repositioned correctly. These relationships are maintained with rebar constraints. Rebar constraints can constrain a rebar to a concrete element, the element's cover, or other rebars. Rebar couplers can connect rebars and automatically apply end treatments and lengths to comply with bar engagements. The couplers can be applied to individual bars or rebar sets. Rebar couplers can also be applied to one end of a rebar for anchor heads. Rebar couplers can appear in schedules and can be tagged. Go ahead and open up the model 017, work with reinforcement tools. The model opens in a 3D view. We'll begin by zooming up on this second column detail here. And what we're going to look at first is applying rebar constraints. For example, you can see here that we have an L bar and the main reinforcement bar of our column. If I select this main reinforcement bar here and I change the bar type to perhaps a number 11 bar, you'll notice that the L bar doesn't move, and in fact now there's a clash between the two reinforcement bars. To stop this clash happening and to make the bars update intelligently, I need to add a rebar constraint between the two reinforcement bars. To do this, I'm going to select the L bar, and on the context ribbon, I'm going to select Edit Constraints. Now in a 3D view, I first select the L bar, and you can now see I have the plane that I want to constrain to, and I can either select a cover here or another reinforcement bar. So in this case, I'm going to go ahead and pick my main bar here. And you'll now notice that I have the distance of clear space in between the two reinforcement bars. Now I can toggle that so I can go from bar center to the tangent faces of the rebar. Here, if I want to give a gap, I can do that. So for example, if I wanted a 1-inch gap in between the two bars, I could type in 1 inch and you can now see the bar moves. Of course, if I want to go the other way, I can type in -1 inch and the bar travels in the opposite direction. Here, we'll set this to 0. On the context ribbon, I can now click Finish. And now, if I select my main reinforcement bar, and I change my bar type back to bar number 11, you can now see the L bar responds to that change. So now we can guarantee that the reinforcement will update intelligently. Next, we add some rebar couplers to the other column. So here you'll notice that we have some gaps ready to insert some reinforcement couplers. The first thing you might notice here is the gap isn't consistent. You can see there are different gaps between all the reinforcement bars. This doesn't matter. The actual length of the reinforcement bar will update when the coupler is applied. So let's go ahead now and add a coupler. On the structure ribbon, click Rebar Coupler. On the context ribbon, you'll note there are two options. We can place a coupler to the end of a bar. This will be useful for an anchor. Or we can place couplers between two bars. In the Properties palette, in the Type selector, we can then choose the type of coupler we want to apply. Notice here we have our anchor couplers up the top. We also have our standard couplers here, or we have transition couplers between different types of bar. So then we can go ahead and place our coupler. We can then continue to place those couplers out, and we'll put the final coupler in. Once the couplers are created, you'll now notice that the distance between the two bars is precisely controlled by the engagement inside the coupler family. For example, if I select one of these couplers here, and I select Edit Type, you'll notice in the type properties that we have things like external diameter, but here we have the bar engagement, and this automatically lengthens or shortens the reinforcement bar to match that engagement. After completing this lesson, you will be able to understand freeform rebar, understand multi-rebar annotations, and annotate rebars with tags. The objective domains covered are 1.1h, work with reinforcement tools, and 3.1d, annotate rebar. Freeform rebar can be added to complex, irregular shapes, both as regular distribution or variable non-planar distribution. Rebars can be straight and deflect on fixing or bent into the desired shapes. Multi-rebar annotations allow fast and efficient detailing of rebar sets. The multi-rebar annotation is a combination of a rebar tag and a dimension. Multi-rebar sets can be detailed with a single multi-rebar annotation and can then be grouped together. Go ahead and open up the model 018, work with reinforcement tools. The model opens in the 3D view, 3D curved slab. This particular slab has been isolated in 3D just to help us visualize the reinforcement. Our task here is to provide reinforcement for this curved slab, and to do this we will use freeform rebar. On the structure ribbon, select rebar. As we're in a 3D view, the default placement method is freeform rebar. The distribution type can either be aligned or surface. So I'm going to begin by taking a look at surface distribution. The first prompt on the cursor is to select the host surface. So the top face of my slab will host the reinforcement. To progress the command forwards, I can either press spacebar or I can select the start surface from the context ribbon. So this will be my starting surface. And then I can select end surface. This will be my ending surface. And then we can go ahead and press enter to finish the command. One curved rebar is now created. We'll select that reinforcement, and on the context ribbon, we'll create a rebar set. We'll use maximum spacing and set a spacing of 10 inches. We can then select that reinforcement bar, and in the properties palette, set the view visibility states. So here we'll view this unobscured and view as a solid. To create the next layer of reinforcement bar, we'll go back to the structure ribbon and select rebar again. Once again, freeform rebar is the default as we're in the 3D view. This time we're going to use aligned distribution. So we're now going to pick the host surfaces for our new rebar. So here we're going to pick the top surface and also the side surfaces of our slab. Our desired output here is to have U-bars. Once we've picked the host surfaces, we can then select the path that the reinforcement will travel down. And again, we can press enter to finish. And you'll now note our reinforcement bar is created. I'll select that reinforcement bar and once again create a rebar set. We'll set the spacing to 10 inches and again edit the view visibility states. And our reinforcement is now complete. If I select the curved rebar and we look at the properties, you'll note here that the workshop instructions are currently set to keep straight. Therefore, the shape is 0, 0, and this bar will deflect on fixing. Another option would be to say bend, and you can see then that if we bend this bar, then it becomes shape code 9. So in this case, we're going to keep straight. Okay, so our freeform rebar is now complete. Next, we add multi-rebar annotations and tags to detail a reinforcement layout. In the project browser, go ahead and open up Rebar Detail A. Here we have rebar sets with just a middle bar showing. To place a multi-rebar annotation, select the Annotate ribbon and then select Multi-Rebar Annotation. We can then select a rebar set and then place out the annotation. We'll place another annotation on this rebar set here. Once the multi-rebar annotation is placed, we may want to adjust the dimension part or perhaps the tag part. At the minute, the multi-rebar annotation is a combination of a dimension and a tag, but I can use the tab key to cycle between these two options. So here, for example, I could move the dimension value out the way. Here, I might want to straighten up the text on the tag, so again, I can use the tab key, and then I can just tweak the position of that tag. We can also add standard tags to reinforcement. So here on the slab, you'll notice that we have another rebar set, and I might want to now detail this in section. Again, on the Annotate ribbon, I can now select Tag by Category. I can then select the reinforcement bar, and a tag is placed. If I then go ahead and select that tag, in the Properties palette, in the Type selector, I have different styles of tag to report on different information. And again, on the Options bar, I might want to remove the leader and position that tag at an appropriate place. Once we have a tag placed out, we can select it, and then perhaps we might want to use something like copy, and we can then copy that tag to other locations. Okay, so our detail is now complete. After completing this lesson, you will be able to understand selection methods, create selection sets, edit selection sets, and load selection sets. The objective domains covered are 1.3a, use selection sets. Most of the editing commands in Revit require a selection set to be defined. In order to complete this task efficiently, you should understand a few fundamental tools for selecting elements. Select all instances is a fast and efficient method of collecting multiple elements of similar properties. Filter is used when multiple families are selected and you wish to remove certain items from the selection. Once a selection set has been made, you can save this set for future use. This tool is found on the Manage ribbon. To recall previous selections, use the Load Selection tool, also found on the Manage ribbon. Go ahead and open up the model 019 Work with Selection Sets. The model opens up in a 3D view. We'll begin by looking at Select All Elements in a view. If I select one of these concrete columns here, and then right mouse click, you'll note that I have a very fast way of selecting all elements similar to this one. I have two options, Visible in View or in Entire Project. In this case, I'm going to use in Entire Project. Up on the Context ribbon, you'll note here that we have the Filter tool. Let's select Filter. In the Filter dialog, I can confirm that I just have structural columns selected and I have a count of 26 items. Go ahead and select OK. This time, I'm going to use a window selection to select the entire model. I can then go up to the Context ribbon and select the Filter option once again. This time you'll note that we have multiple categories selected. If I just want the structural columns to be selected here, I could select Check None, and then select Structural Columns and click OK. We now just have structural columns in the selection set. These selection methods are relatively simple to achieve. However, if we zoom up on the steelwork on the roof here, you'll notice in this section here, we have these parapet support beams that I might want to select. Now, all of these parapet support beams are fairly short in length. Now, of course, I could hold the control key down and then go around and start to manually select all of these, but there is a quicker way to do that. If we look in the project browser, you'll note that I've set up a structural framing schedule that just reports on the framing organized by its cut length. Now I can see here that all of these framing members using the HSS 3x2x1/8, I can select all of these here and then select the 3D view again. Just to ensure that I have only selected those parapet support beams, I can go ahead and utilize isolate elements. And now I can just confirm that I have those parapet support beams selected. Let's go ahead and reset my temporary hide isolate. Now what I can do here is I can save this selection set so that I can record it at a later date. Let's select the Manage ribbon, and on the Manage ribbon you'll note here that I can in fact save a selection. We'll name the selection set Parapet Support Beams and click OK. The selection set has now been saved. If I want to record a selection set, I can pick something else just to remove the selection. And then on the Manage ribbon, I can load selection set. And in here, you'll note that I have my parapet support beams that I can select and click OK. Finally, I can edit a selection by going to the Manage ribbon and selecting Edit Selection. Here you can see that I have some rule-based filters set up, but here our selection filters are displayed. So you can see here that I have my parapet support beams. Here I could edit the selection set. In this example here, I could select some of these and remove or add them using the context ribbon up here. Or, in fact, I could simply just delete the selection if I wanted to. After completing this lesson, you will be able to understand materials, create a new material, and load a material library. The objective domains covered are 1.2a, associate a material with an object or a style, 1.2b, create and edit a basic material and its properties, and 1.2c, load a material library. Materials control how elements appear in various views and renderings. Materials can also have an impact on structural analysis and hence should be carefully managed. The Materials Browser dialog contains all of the required tools to manage and create new materials. Go ahead and open up the model 020 using and modifying element materials. The model opens up in a 3D view. We'll start by looking at the Materials Browser dialog box. On the Manage ribbon, select Materials. In the Materials Browser dialog box, you'll see this is split into two areas. The panel on the left-hand side allows us to browse all of the assets in our current document. The panel on the right-hand side contains Asset tabs. These various different tabs control things like graphics, appearance, physical, and so on. Let's search for a particular grade of steel. So here I'm going to type in ASTM. A search is then performed on all the assets in my current document. And you'll see here that we have a particular steel called steel ASTM A53. Let's now review some of the asset properties. So you'll notice I'm on the physical tab, and here I can review the mechanical and strength properties. Like we said earlier, this can be utilized for structural analysis. We can then review the appearance. Here we're using this paint enamel glossy blue. Then we can review the graphics tab here. This would affect 2D and 3D views, whereas the appearance tab only affects rendered views and views that are using the realistic appearance. What we're now going to do is produce a copy of this steel and simply just change its color. So let's right click over it and then we'll duplicate this. You'll now notice that we have a copy, and I'm going to keep the same grade of steel the same here, but we'll just simply type in the color red afterwards. Now, in order to change this, I'd also have to change the material that it's using in this Appearance Asset tab. You'll note here that we're currently using Paint Enamel Glossy Blue. Let's go ahead here and replace this asset. In the Asset Browser dialog box, I will do a search for red. You'll see here that we have Paint Enamel Glossy Red. To utilise this, we'll simply double click. You'll now notice that that's passed directly into the Materials Browser dialog. Once we've done this, we can simply close the Asset Browser. You'll now notice that I have two materials. I have my blue steel and my red steel. Also note on the Graphics tab, we have this same red colour utilised here because we've checked Use Render Appearance. Let's go ahead and select OK to our Materials Browser dialog. We'll now change the material on these three slanted columns. With the Control key held down, select the three slanted columns in the model. In the Properties palette, you'll note that we have an instance property for structural material. This button here will allow us to browse to the Materials Browser. And of course here we can now select our new material, Steel ASTM A53 Red. And there's our new material applied. Finally, you go ahead and load a predefined materials library. On the Manage ribbon, select Materials. In the Materials Browser dialog box, in the bottom left, you'll note here with the drop-down menu, you can open an existing library. Go ahead here and select the ACP Materials library from your dataset and click Open. The Materials library is now open. Let's search this by typing in the word concrete. When we open up the Materials library, we'll now notice that we can view all of the materials that match concrete from the AEC Materials library or our ACP library. Go ahead and click OK to the Materials Browser dialog.